A huge asteroid, several hundred feet across, is dashing towards Earth through the black nothingness of the cosmos. Ooh. Brace for the terrible news. There's a 72% chance it might hit Earth in 14 years, with potential impact zones being North America, Southern Europe, and North Africa, some of the most densely populated areas on the planet. Astronomers have been keeping a close eye on the space invader for a few months, but now it's moved too close to the Sun, and tracking it is impossible for the next 7 months. Of course, there's a 28% chance that it will miss our planet altogether. But what if it doesn't? Global devastation and destruction, that's what. Thousands of lives lost, billions and billions of dollars in damage, entire species wiped off the face of the Earth, ruined cities and towns, destroyed fields and forests. We're left wondering whether it's the future awaiting for us. Well, now you can breathe easy. That's just a hypothetical scenario created by NASA to prepare for a situation like this. The space agency has been thinking about this kind of disaster for years. Even cooler, they run what-if asteroid exercises every 2 years to get scientists, state agencies, and international experts on the same page. The last one occurred in April. Over 100 people took part in that event. During such asteroid drills, experts pretend that a giant space rock is heading our way. Then they work through all the tricky questions they can come up with, like how big is it? Where might it hit? What should we do? It's like a massive brainstorming session to make sure that if it ever happens, we won't have to start from scratch. To make these scenarios feel as real as possible, NASA's Center for Near-Earth Object Studies gets involved. These are folks who track real asteroids and calculate their orbits. So they simulate months of asteroid observations, complete with uncertainties about its size, trajectory, and potential impact zones. It's the kind of uncertainty that makes decision-making way harder, just like it would be in real life. Now, if an astronaut really was aiming at Earth, it wouldn't be just one country's problem. It would be everyone's. That's why this exercise brings in international experts. In April, it happened for the first time. They worked alongside U.S. agencies like NASA's Planetary Defense Coordination Office and FEMA to understand how the world might respond to such a crisis, since an asteroid impact would have dire consequences globally. Now, the big question is, can we actually stop an asteroid from hitting Earth? Here, there are two main options experts consider. First, we could send a spacecraft to gather more info. If we knew more about the asteroid's size, mass, and orbit, we'd be able to make better decisions about what to do next. The second option is to try to deflect it. Basically, it means bumping the asteroid off its course so that it misses Earth. This might sound impossible, but NASA's DART mission has already proven that we can do it. 2 years ago, they crashed a spacecraft into a small asteroid called Dimorphos and successfully changed its orbit. It was a huge victory for planetary defense. But missions like that take tons of time to plan, prepare, and carry out. That's why spotting dangerous asteroids as early as possible is so important. Currently, NASA is working on a new telescope called NEO-Surveyor, which is set to launch in 2027. Unlike good old telescopes, NEO-Surveyor is designed to detect even the trickiest asteroids, including ones orbiting close to the Sun. It'll give us a better chance to act early and potentially stop an asteroid before it becomes a threat. If you still think that an asteroid impact is something out of science fiction and the threat isn't real, how about this? Early on Sunday, January 21st, a small asteroid about 3 feet wide entered Earth's atmosphere and luckily burned up over Germany. NASA's Scout Impact System spotted it 95 minutes before it hit and predicted exactly when and where it would arrive. At 1:32 a.m. local time, the asteroid turned into a blazing bright fireball, visible as far away as the Czech Republic. Some small meteorites might have landed near the impact site, about 37 miles west of Berlin. This is just the 8th time ever that an asteroid has been detected before it hit Earth. It's a splendid example of how tools like Scout are helping us track asteroids and prepare for anything bigger that might come our way. Here's another example. A small asteroid turned the skies over northeastern Siberia into a breathtaking light show on December the 4th, burning up harmlessly in Earth's atmosphere. The space rock, about 28 inches across, was spotted just hours before it hit. Thanks to observations from astronomers around the world, a special alert system managed to predict the impact to plus or minus 10 seconds. The asteroid entered Earth's atmosphere at 1:15 a.m. local time. The authorities were put on alert, but there was no damage reports. NASA's Asteroid Terrestrial Impact Last Alert System, or ATLAS, spotted the rock 12 hours before it entered the atmosphere. This makes it the fourth imminent impactor, which is an asteroid discovered within hours of its expected impact, detected this year, and the 11th overall. Now, China also has big plans for planetary defense. They're working on their first mission to hit an asteroid, and it's got a double purpose. One spacecraft will crash into the asteroid, and the other will hang back to study the whole thing for up to a year. In other words, it's not just about protecting Earth, it's also a way to learn more about the solar system. The target is an asteroid called 2015 XF261, which is a mouthful, and also about 100 feet wide. It flew by Earth recently on July 9, passing us at 31 million miles. True, it's pretty far away, but the space traveler was zooming by at a speed of 26,000 miles per hour, 30 times faster than the speed of sound. China is going to send a space probe to study the asteroid. They're hoping to learn more about its structure and composition, which could help us with future planetary defense missions. Then they plan to hit the asteroid with another spacecraft to test the impact, and the first space probe will stay there to observe the remains for up to a year. Timing is critical for this mission, and the asteroid offers some good opportunities in the next few years. Thus, in March and May of 2027, the asteroid will pass within 20 million miles of Earth. In April 2028, it'll get even closer. By that I mean 13 million miles away. A year later, in April 2029, the asteroid will end up just 4.2 million miles away, making it the best shot for a mission. Another decent chance will be April 2030. That's when the asteroid will pass our planet at 4.4 million miles. To give you some context, NASA's DART mission once targeted an asteroid 7 million miles away, and the trip took 10 months. So China's planners have to pick the right moment, depending on how long their spacecraft will need to get there. The mission is expected to start around 2027. At the same time, this won't be China's first attempt to target an asteroid. Back in 2023, they were planning a planetary defense test with a different asteroid, which is also about 100 feet wide. It's not clear why they switched to the current one, probably because the timing works better. Most asteroids are basically time capsules from 4.6 billion years ago, leftovers from when the solar system was just forming. Studying them could tell us a lot about how planets, including Earth, came to be. So, China's taking on something that combines planetary defense and pure space science. They're definitely making big moves in the space exploration game. So, how do you feel about cooking? Nah, pasta and burgers are overrated. How about something more exotic, or rather, more cosmic? So, the recipe is simple. Take a team of enthusiastic astronomers and add some old images from the James Webb Space Telescope. Stir really well, and you'll get a shocking number of tiny asteroids in the asteroid belt between Mars and Jupiter. Yummy! The highlight of this dish is the direction in which some of the asteroids are moving, because in their way, there's our poor planet. Are we doomed just because you decided to cook? Now, the asteroids I'm talking about are much smaller than the massive space rock that wiped out the dinosaurs, but they can still cause considerable damage. They range in size from as small as a bus to as big as a stadium. But even those small ones pack quite a punch. Let's look at a recent dramatic example. It happened on February 15, 2013. A small asteroid just tens of feet wide exploded in an airburst over Chelyabinsk in Siberia, releasing an insane amount of energy. Many people witnessed and recorded the event, and it gave scientists vital clues. New computer models helped scientists reconstruct the size, speed, and impact of the Chelyabinsk meteor. It was likely an asteroid, about the size of a 5-story building, exploding from 15 to 18 miles above Earth's surface with an enormous, incomparable force. The blast shattered 1 million windows and hurt over 1,000 people. Fortunately, it wasn't powerful enough to cause too much damage, but it gave us an idea about how dangerous an airburst can be. Now, an airburst occurs when an object explodes high in the atmosphere, never striking the ground, but releasing enough energy to devastate the area. But back to the small asteroids. The most dangerous thing about them is that they hit the Earth far more often than the larger ones, about 10,000 times more frequently. To make matters worse, their small size makes them harder to detect in advance, leaving little time for preparation if one is heading towards Earth. Now let's travel back in time. Uh-oh, dinosaurs, too far back. Ah, there we go. A team of astronomers is working on a special method to find small asteroids in telescope images that were originally taken to study distant stars. Using this method, they've looked through thousands of JWST images of a star system called TRAPPIST-1. It's located 40 light-years away and is one of the most studied systems outside our solar system. Now, while analyzing these images, they discovered 138 new asteroids in the main asteroid belt, plus 8 they already knew about. And guess what? Among the newly found asteroids, 6 seem to have been pushed into paths that could bring them closer to Earth. Who did it? Well, probably nearby planets. Are they holding a grudge against Earth? Interestingly, scientists thought they'd find just a few new asteroids, but the number was much higher than they expected. Yet, it's no wonder. Right now, they're exploring a part of space they didn't know much about before. Now, let's talk about the hero of the day, the James Webb Space Telescope. It's especially good at finding small asteroids because it can detect their heat. These asteroids give off infrared radiation, which is much easier to see than the faint sunlight that reflects off their surfaces. This technology allowed scientists to spot the smallest asteroids ever seen in the main asteroid belt. The asteroids they found are pieces left over from collisions between bigger space rocks. Finding them helps astronomers understand the history of the asteroid belt and improve methods for tracking small asteroids that could threaten Earth. The researchers are planning to use James Webb to observe other star systems for at least 500 hours. They expect this work to uncover thousands more small asteroids in the solar system. Other advanced telescopes, like the Vera C. Rubin Observatory in Chile, will also help. Starting in 2025, this observatory will use the world's largest digital camera to photograph the southern sky every night for at least 10 years. Each image will cover a huge area of the sky, about 40 times the size of the full moon. The observatory might find up to 2.5 million asteroids in just 6 months, almost doubling the number we know about. Recently, NASA has identified 2 small asteroids. They were supposed to pass near Earth on December 16, 2024. Luckily, neither posed any danger to our planet. The first asteroid was 71 feet wide, about the size of a large airplane, and was traveling at 10,800 miles per hour. The second asteroid was slightly smaller, 56 feet wide, but it traveled faster at 14,700 miles per hour. But hey, even though this time the danger is past, who knows what the future will bring? It may sound weird these days, but astronomers didn't really care much about small asteroids for a rather long time. They thought of them as just random space debris that got in the way of observing stars. Some even called them sky parasites. But now, the way we see these little space rocks has completely changed. You see, until recently, we could only spot really big asteroids, those over a mile wide. The smaller ones just blended into the background noise in telescope images. But then, a clever trick appeared where multiple images of the same part of the sky were combined, making those faint small objects finally stand out. The data from certain telescopes, along with the James Webb Space Telescope, helps us improve planetary defense. But there's more to it than just protecting our planet. Studying these small asteroids also teaches us about how the solar system evolved. There are so many of them because they're fragments from collisions between bigger space rocks. One researcher has said this is like looking at old data in a new way. These small asteroids, which people used to think of as space junk, are crucial for understanding our solar system and even preparing for whatever the future holds. Among those hundreds of millions of rocks orbiting the Sun in the asteroid belt between Mars and Jupiter, some are especially worrisome. They come close enough to Earth for it to be quite concerning. NASA classifies asteroids that orbit within 30 million miles of our planet as near-Earth objects, and those could pose a serious threat if they were to collide with our planet. Right now, NASA is closely monitoring an asteroid named Bennu. This is a fairly large space rock, measuring about 1,600 feet across. It could, potentially, crash into Earth in 159 years. First, the astronauts spotted it in 1999. So currently, experts believe that there's a small chance Bennu could drift into Earth's orbit and collide with our planet by September 24, 2182. Would it be bad? Well, to put it in perspective, Bennu is taller than the Empire State Building. If it hit Earth, it would generate 1,200 megatons of energy, an amount so massive that nothing on Earth could generate that. NASA scientists are particularly concerned about a tiny chance that Bennu could pass through a gravitational keyhole during a flyby in the 22nd century. This keyhole is a region in space that could set the asteroid on a path that brings it directly to Earth. Now, Bennu flies by Earth every 6 years and has had 3 close encounters with us in 1999, 2005, and 2011. Right now, scientists estimate that the chance of Bennu hitting Earth by 2182 is about 1 in 2,700, more than 5 times greater than the chance of being struck by lightning. Although the chances of Bennu colliding with Earth are very low right now, this space rock is still classified as a potentially hazardous asteroid because it might come as close as 4.65 million miles to Earth. Now, this asteroid is another space rock that we need to keep an eye on. It's a near-Earth object about 1,100 feet across, and it was discovered in 2004. Initially, it was considered one of the most dangerous asteroids ever detected. Apophis quickly gained attention because experts believed it could pose a serious threat to Earth because of its close approach to our planet in 2029. However, after further study of its orbit, astronomers determined that there was no risk of a collision for at least a century. Well, we can all breathe easier now, can't we? In February 2025, scientists detected an asteroid heading our way. If it hit, it would create a crater the size of Manhattan and unleash a shockwave strong enough to flatten everything within 30 miles. Uh-oh, I'm out of here. Well, luckily for now, we're in the clear. But the threat is coming back in 2028, and this time, everything might change. You see, in 2025, NASA announced that an asteroid called 2024 YR4 had a 3.1% chance of hitting Earth in 2032. Now, in asteroid terms, that's high enough to sound the alarm. The asteroid itself is not the end of the dinosaurs level, but it's big enough to level a city. The rock is about 130 to 300 feet wide. That's roughly the size of a large jet. Now, if something that size slammed into a populated area, it wouldn't end the world, but it would result in a very, very bad day. And still, no one panicked, and scientists weren't scrambling for bunkers. Because when we first spot an asteroid, we have to work with limited information. It's like seeing a plane high up in the sky and trying to guess exactly which gate it'll park at. That's why astronomers rush to gather more data. The asteroid itself seemed pretty ordinary. It was rocky, not some rare metal thing. It was first spotted in late 2024 by an observatory in Chile during a regular skyscan routine. There's this group called the International Asteroid Warning Network. Their job is to keep an eye on space rocks that might try to ruin your day. And back on January 29, 2025, they announced that the chances of that particular asteroid hitting Earth had gone over 1%. Now, 1% might not sound like much, but that's enough to make scientists start worrying. The impact risk for 2024 YR4 reached its highest point on February 18, 2025. That's when scientists calculated a 3.1% chance it could hit Earth. But by February 23rd, after more observations came in, that possibility was essentially ruled out completely. The asteroid's Torino scale rating, which is used to categorize the impact risk of near-Earth objects like asteroids and comets within the next 100 years, was lowered to 0. It means it's no longer considered a threat to Earth, well, for now. But scientists still keep tracking it, and based on additional data, there is now a 4% chance it could hit the Moon instead. If that were to happen, it would be on December 22, 2032. Right now, the asteroid is expected to pass about 5,600 miles from the Moon's surface. However, there is a very large uncertainty range, about plus or minus 46,000 miles, so it could easily miss the Moon by a very large distance. The last time we had something this dangerous was back in 2004, with an asteroid called 99942 Apophis. Back then, it had a 2.7 chance of hitting Earth in 2029. People were sweating. But after better observations, scientists ruled out the impact. This time we actually passed that old record. 2024 YR4 is currently heading out toward Jupiter's neighborhood and won't swing back close to us until 2028. And that's when everything might change. If the risk jumps above 10%, the IAWN will send out a formal warning to the United Nations. They'll tell countries in possible impact zones to maybe start preparing, because if we talk about the damage… Admittedly, this asteroid is not the 6-mile-wide monster that wiped out the dinosaurs 66 million years ago after hitting Earth. This here asteroid is in the city killer category. It sounds dramatic because it is, but it's not some global extinction stuff. The real problem isn't just its size, it's its speed. If the asteroid hits, it could be moving nearly 40,000 miles per hour. That's like flying from New York to LA in under 5 minutes. But still, the most likely scenario would be the asteroid exploding in the air before even hitting the ground. That's called an airburst. But if the asteroid is on the bigger end of the size estimates, it could actually reach the surface of our planet, slam into the ground, and make a crater. So that possibility's still on the table. As for where it could hit, the possible impact zone covers a huge area: Eastern Pacific, Northern South America, the Atlantic, Africa, the Arabian Peninsula, and South Asia. Raise your hand if we left you out. Keep in mind, though, that it's way too early to make life decisions based on that. So, no packing up and moving yet. Besides, we're not sitting here helpless. In 2022, NASA pulled off the DART mission, where they literally smashed a spacecraft into an asteroid to nudge it off course. And it worked. DART stands for Double Asteroid Redirection Test. It was built for NASA's Planetary Defense Office. They wanted to know if we could push an asteroid just enough for it to miss our planet. So they launched a spacecraft in November 2022, and it traveled through space for about 10 months. The plan from day one was to crash it. The target was a small asteroid moon called Dimorphos, which is about 530 feet across, the size of a large stadium. Dimorphos orbits a bigger asteroid called Didymos. The two of them just circle each other out there in space. What's important is that neither of them was threatening Earth, so this was a safe test. Now, DART was basically a heavy spacecraft with a camera and a smart guidance system. The strategy was to hit Dimorphos at about 14,000 miles per hour and let the force of that impact slightly change its orbit. In the final stretch, the spacecraft guided itself. It had to figure out which rock was which, lock onto the smaller one, and adjust its path without anyone steering it in real time. When it hit, the onboard camera sent back close-up images right up until the moment of impact. Then the signal stopped because the spacecraft had done its job and smashed into the asteroid. There was also a small Italian CubeSat that separated earlier and stayed back to photograph the collision and the resulting debris cloud. Those images showed a huge plume of rock and dust blasting out into space. Well, after that, astronomers around the world started measuring the orbit of Dimorphos very carefully. Before the collision, it took 11 hours and 55 minutes to circle Didymos. After the impact, it took 11 hours and 23 minutes. That's an impressive 32-minute difference. The interesting part was that the spacecraft alone wasn't responsible for all of that shift. When DART struck the surface, it threw tons of rocky material outward. All that rock and dust blasting off gave the asteroid an extra push, stronger than the spacecraft alone could have done. Scientists later realized that Dimorphos wasn't a solid chunk of rock. It was more like a loose pile of rubble held together by gravity. That probably helped produce more debris and a bigger push. So if we ever face a denser, more solid asteroid, the same technique might not have the same exact effect. That's why scientists are also looking at other ideas, like using lasers to heat up part of the asteroid so bits of rock fly off and slowly push it in the opposite direction, like giving it a tiny built-in rocket. Or they could place a spacecraft close to the asteroid and use its gravity to slowly pull it off course, like a small tugboat guiding a huge ship. Or if things got really serious, use a nuclear blast as a last resort shove. Despite the success of the DART mission, NASA says we do not have a ready, reliable system that could stop a city-killing asteroid if one suddenly shows up on a collision course with Earth. The danger isn't the giant dinosaur-level asteroids. Those are huge and easy to track. Neither is it tiny rocks that burn up in the atmosphere all the time. It's the middle-sized ones, around 500 feet wide. Scientists estimate there are about 25,000 near-Earth objects in that size range moving near Earth's orbit. So far, we've only found about 40% of them. That means most of them are still out there, and we don't know exactly where they are. The problem is, they're dark. Most don't reflect much sunlight, so even powerful telescopes can miss them. To help fix that, NASA plans to launch a new space telescope called the Near-Earth Object Surveyor. Instead of looking for sunlight bouncing off asteroids, it'll look for heat. Even a dark asteroid absorbs sunlight and gives off heat, and that's easier to see in infrared. Astronomers just spotted an asteroid roughly the size of 8 football fields. It spins so fast that it completes a full rotation in just under 2 minutes, which makes it the fastest asteroid ever found in its size class. If this bad boy hits Earth, the consequences will be, well, let's just say everyone will notice. You think? Scientists caught MN45 using early data from an observatory on a mountaintop in Chile with a 3,200 megapixel camera. Ooh. It will be scanning huge areas again and again for 10 years to catch what moves, what flashes, and what wasn't there yesterday. The SuperCam takes an image every 40 seconds, and that's how it noticed MN45. The same equipment recently caught around 2,000 other asteroids, but our hero definitely stands out. Now, an asteroid spinning this fast probably didn't start life as a calm, normal space rock. Scientists think a past collision could have smacked it hard enough to spin it up like a toy top. And if that impact was violent enough, MN45 might not even be the original asteroid, but a fragment that broke off from a much larger parent object. Basically a piece of a bigger monster that got shattered long ago. Spinning fast in space isn't just a flex, it's dangerous, because rotation creates stress, and stress tries to rip an asteroid apart. If a space rock doesn't have enough internal strength, it doesn't stay one object. It fragments into smaller pieces, like a cookie that cracks when you twist it too hard. That's why most asteroids never spin this fast. Most of them aren't solid boulders. They're rubble piles, basically space gravel held together by weak gravity, like a floating clump of broken rocks. Astronomers have a kind of speed limit for asteroids. In the main asteroid belt between Mars and Jupiter, a typical rubble pile asteroid needs to rotate more slowly than about 2.2 hours per full spin to stay intact. Anything faster than that starts entering the danger zone. So if an asteroid spins faster than this limit, and it's still big, that's a massive clue. It must have unusually strong material inside, like solid rock or something even denser. Because if it were weak and crumbly, like most asteroids, it wouldn't be spinning. It would already be a cloud of debris. The good news is that this hard rock asteroid isn't coming for Earth. It's at a safe distance from us, up in the asteroid belt. But its existence screams something terrifying. If something this big and this extreme stayed unnoticed until now, what else could be hiding out there? Perhaps the real threat isn't one record-breaking spinner, but a blind spot. Some simulations show that there could be a whole swarm of hidden city-killer asteroids hanging around Venus like cosmic pickpockets. As you can guess from the name, these asteroids are large enough to destroy an entire city. The reason they're so hard to catch is that they hide in sunlight. From Earth, the area close to the Sun looks bright and washed out, which makes it easy for objects near Venus's orbit to blend into the glare. It's like trying to spot a black cat in a dark room when someone shines a flashlight straight into your eyes. And this is where it gets personal, because humans love pretending we control space. But these Venus-hiding asteroids don't care. Their orbits can shift slowly over time because of gravity nudges and long-term motion. And that means one of them could eventually get pushed onto an Earth-crossing path. Not today, not tomorrow, but someday. And in asteroid terms, someday always arrives faster than people expect. Now let's talk about a completely different kind of dangerous asteroid, Bennu. Now Bennu isn't a solid rock freak like MN45. Bennu is a rubble pile, a loose, clumpy near-Earth asteroid about 1,600 feet wide. It's famous because NASA actually went there. The OSIRIS-REx mission grabbed samples and brought them back to Earth. And what scientists found inside was straight-up mind-blowing. There were life-linked elements, including sugars like ribose and glucose, plus a weird gum-like organic material, and even ancient stardust. Down on Earth, ribose helps build RNA, and deoxyribose helps build DNA. DNA and RNA are basically life's instruction manuals. They store information the way a hard drive stores files. But before you get too excited, no, finding these sugars on Bennu doesn't mean it had life. But it does mean the building blocks needed to build biology weren't rare or special. They were everywhere, floating around in the early solar system. Scientists have already found ribose before in 2 meteorites that landed on Earth, so it's not totally unusual. All that is cool and totally benign, but Bennu has a scary side too. It isn't likely to hit Earth, but researchers still model it because it has a very small chance of impact in the late 2100s, including around 2182. And if Bennu hit, it wouldn't wipe out dinosaurs again, but it could wreck climate patterns, blast huge regions, and trigger global-level effects, depending on where it struck. Bennu is like the perfect reminder that space can carry both the ingredients of life and the power to erase it. And if you want more reminders like this, space is like a gallery of cool asteroids. Take Ceres, for example, which was first classified as a planet, then demoted to an asteroid, and then promoted to a dwarf planet again. Hey, talk about an identity crisis. One thing is for sure, it's basically the boss of the main asteroid belt between Mars and Jupiter. No matter what label you slap on it, Ceres is a cold ball of rock and ice about 600 miles wide. Living there would feel like surviving on hard mode. Ceres has no substantial atmosphere, so you need a spacesuit just to breathe and to avoid freezing. Daytime temperatures range from about -136 to -28 degrees Fahrenheit, and at night it drops to around -225. But you'd also feel ridiculously light, because Ceres' gravity is only about 3% of Earth's. A 150-pound person would feel like 4.5 pounds there. Ceres is like a failed planet, leftover rubble from the solar system forming, a protoplanet that never fully grew up. NASA's Dawn spacecraft went to see it in 2015 and spotted bright white patches that looked like headlights from some strange spaceships. The biggest one sat inside a massive crater. Scientists thought it might be exposed ice, but it turned out to be sodium carbonate, salty mineral leftovers from briny water that bubbled up and vanished into space. Even crazier, that salty water may still come from a reservoir about 25 miles below the surface, and the activity could still be happening today. Life seems unlikely there, but with water involved, it might have existed in the past. Now this guy, Tutatis, another cool asteroid, has a weird double-lobed dumbbell shape. Instead of smooth spinning, it does this chaotic tumbling motion, like someone tossed a wrench into space and it never stopped flipping over. Scientists think part of the reason for this weird movement is that Tutatis might be 2 bodies barely touching. That makes it unstable right away. Then gravity shows up and makes it worse. As Tutatis travels through the solar system, The gravitational pull of Earth and even Jupiter can tug on it, messing with its rotation like invisible hands turning it at random. That's what makes it so unpredictable. It's not just spinning, but constantly getting nudged into new motion patterns. The path it takes through space brings it close to Earth, which sounds terrifying, but the even scarier part is the word chaotic. Scientists determine its orbit for the next few centuries, and it won't collide with Earth in the next 6 centuries. But we don't know what can happen after that. So, as you can see, we don't need to be afraid of every asteroid scientists have spotted, but we might have a good reason to fear the ones they haven't seen yet. So, we just spotted an asteroid so massive it could wipe out an entire continent if it ever hit Earth. And it's moving insanely fast, almost record speed. But what makes it really scary is how it's basically playing hide-and-seek with us. It can slip right into the sun's glare and vanish completely. And yeah, it just did it again. It disappeared. So, when we finally spot it again, will we have enough time to prepare? Or could it already be too late for humanity? Do I have your attention now? Thanks. So, meet 2025 SC79. That's a mouthful, so I'll just nickname it Scooby. This newly found asteroid is a sneaky one, the kind that loves hiding in the sun's glare. Think of it as trying to spot a firefly next to a stadium light. The brightness hits your eyes and outshines anything faint nearby. So yeah, you won't see that firefly. Now asteroids hide in the same frustrating way. When they end up close to the sun from our point of view on Earth, the glare overwhelms our telescopes, and the asteroid's dim, reflected light gets lost in it. That's why some asteroids can cruise along in the sun's direction and stay basically invisible to us. And scientists say the most dangerous asteroids, the ones that could wipe out a whole city, are the hardest to detect. That's why astronomers need to somehow dodge the sun's glare. One way they do it is by observing the sky during the short window of twilight. Right before sunrise or just after sunset. And that timing is a big deal, because it's the only way to catch some risky asteroid before it sneaks up on Earth. Scientists say that if one of these so-called twilight asteroids ever gets close to Earth, it could be a serious impact threat. And it was during one of these twilight observing sessions that scientists finally spotted this huge asteroid. It was September 27, 2025. Scott Shepard, an astronomer at a Washington-based institute, was scanning the sky, hunting for anything unusual in our solar system. And he had an incredible tool in his hands, the Dark Energy Camera, or DECAM, one of the most powerful sky survey cameras on Earth, built to spot faint objects across huge areas of the universe. At one point, he spotted a faint dot moving across the image. So he quickly aimed the high-tech camera at it, and things got more interesting. Its movement matched what astronomers expect from asteroids that orbit very close to the Sun. Then, follow-up observations with the Gemini and Magellan telescopes confirmed the discovery. Yes, this really was an asteroid, and there are 2 particularly curious things about it. First, it's fast, like really fast. In fact, it is the second fastest known asteroid orbit in the solar system. It loops around the Sun once every 128 days. For comparison, Mercury, the closest planet to the Sun, takes 88 days to go around once. Second, its orbit is super rare. This is only the second known object that stays completely inside Venus's orbit. That also puts it in one of the rarest asteroid groups out there, the Asteroids. These are asteroids whose orbits sit entirely inside Earth's orbit. Astronomers have found only a few of them so far, and Scooby is the 39th one in the list. The team of scientists also figured out that this asteroid is pretty big, measuring about 2,300 feet across. That's roughly the size of Merdeka 118, the second tallest building on Earth. If an asteroid this size ever slammed into Earth, it wouldn't just be bad, it would be catastrophic. We're talking about damage on a continental scale. it would blast a huge crater into the ground, then throw out a shockwave powerful enough to wipe out forests and wreck cities. Seismic waves would ripple through the crust, triggering widespread earthquakes around magnitude 7.4, and people could still feel them about 300 miles away from the strike. And that's not all. A brutal air pressure blast would race outward, shattering windows more than 1,000 miles away. Then comes the aftermath. Dust and debris from the impact could shoot up into the atmosphere, block some sunlight, and mess with our climate. I know, you might feel scared right now, but don't worry about it. Thankfully, Scooby isn't going to do anything like that, because it's not on a collision course with Earth. Right now, the math shows it won't be making any close passes by our planet, at least not anytime soon. Still, there's a lot more to learn about this asteroid, but any further studies will have to wait. For now, it has disappeared behind the Sun and is out of sight. Once it reappears, astronomers will take a closer look and try to learn more about what it's made of. That part really matters, because this asteroid is somehow holding up while orbiting so close to the Sun's brutal heat. You see, this asteroid gets very near to the Sun. At its closest point, this asteroid is blasted with almost 6 times Earth's sunlight. At that distance, its surface could heat up to about 440 degrees Fahrenheit. What scientists don't know yet is how a rock this big can get baked over and over again without falling apart. And there are 2 more things astronomers want to check once it comes back into view: how fast it spins and how bright it looks. Now, by bright, I mean how much sunlight it reflects, because asteroids don't make their own sunlight. They're just big rocky chunks that shine by reflecting sunlight back at us. Anyway, those clues can tell scientists what Scooby is made of. One possibility is that this asteroid is loaded with dense metal, and that could explain how it survives the Sun's brutal heat. And if that turns out to be true, this asteroid could be a relic from when the solar system was just forming. Or maybe it slowly moved closer to the Sun because the gravity of Venus and Mercury gently pulled on it again and again over millions of years. Now, even though SE79 isn't a real danger to us, and there's still a lot we don't know about it, just finding it is already a big deal. It's a reminder that big asteroids can hide from us. So even in our own cosmic backyard, there are still blind spots where large objects can stay hidden until the right moment of twilight gives them away. And as our detection tech gets better, we keep finding more and more asteroids. By now, scientists have spotted over 1 million in the solar system. They come in all sizes, from monsters like Vesta that measure about 329 miles wide, all the way down to rocks that are smaller than a house. Now, out of all the asteroids we know, about 40,000 are what we call near-Earth asteroids, or NEAs. That just means their orbits bring them close to our neighborhood. Technically, their closest point to the Sun is less than 1.3 times the Earth-Sun distance. It's close enough for planetary defense systems to keep a careful eye on them. And that's exactly why we can relax. I mean, nobody has to lose sleep imagining an asteroid slamming into our planet. Every time scientists discover a new asteroid that comes anywhere near Earth, they track it and run the numbers right away. And then they map out its path years, decades, or even centuries into the future. And they don't do it by guesswork. NASA's automated systems, like Sentry, constantly scan the asteroid catalog and calculate whether any of these objects has even a small chance of hitting Earth over the next 100 years. If something looks risky, it jumps to the top of the watch list and gets followed up fast. So yeah, there are almost 2,000 near-Earth asteroids that technically have some chance of hitting us in the next 100 years. But don't panic. Most are small and harmless, hey, like me. And their odds of impact are usually way under 1%. See why I said we shouldn't stress too much? Cool. Now, sleep tight. Asteroids, unseen but perilous, are traveling in the same orbit as Venus, and our telescopes just can't detect them. The threat is real, If one of these objects heads toward Earth, we're all doomed. Well, maybe. In that not-so-distant, relatively of course, stretch of space where Venus orbits, there may be hundreds of asteroids we've never detected. They could be circling the Sun right at this moment, but they stay completely hidden from us. The problem is their position. Because they're closer to the Sun than Earth is, we can only look for them by pointing our telescopes almost straight toward the Sun. Any sunlight they reflect gets swallowed up by the Sun's brightness, so they basically disappear in the glare. These objects aren't part of the main asteroid belt between Mars and Jupiter. They're much closer, moving through the inner solar system. They travel in what's called a 1-to-1 resonance with Venus. It means they orbit the Sun in almost the exact same period as the planet. This makes them Venusian co-orbital asteroids, rocks that orbit the Sun in the same area as Venus instead of having their own separate path. Now, researchers use computer modeling and long-term simulations to figure out how these hidden asteroids behave and whether they could ever threaten Earth. The results aren't reassuring. The orbits of these asteroids aren't stable, their paths shift over time, and about every 12,000 years, their whole orbital setup can change. An asteroid that stays close to Venus for thousands of years can eventually drift away from it and come much closer to Earth's orbit. Now, Jupiter has its own group of co-orbital asteroids called Trojans, but those are much more stable, and the planet is so far from us that even unstable ones wouldn't be a problem. The Venus co-orbitals are different. They're close, and their orbits can change enough that some of them may eventually cross Earth's path. So even though these asteroids are invisible to us right now, the models suggest that some of them could one day get close enough to pose a real risk to our planet, even if that risk is thousands of years away. Now, even worse, scientists think that the small number of Venus co-orbital asteroids we've already discovered is only a tiny sample of what's actually out there. They suspect that most of this population is still completely unseen. Some of these hidden objects may be almost 1,000 feet wide. Such an asteroid is large enough to create a crater about 2 to 3 miles across if it ever hits Earth. Oh boy. An impact of that size would release energy equal to hundreds of megatons, causing massive destruction if it happened in a densely populated region. An asteroid would slam into the planet with enormous force, turning solid rock into vapor. Everything, and everyone close enough to see the crash, wouldn't live long. The ground around the impact crater would be covered with hot ash, grit, and rubble. Grass, trees, and shrubbery around the crash site would burst into flames. But that's not the worst thing. The impact would trigger a series of natural disasters, such as tsunamis and earthquakes, depending on the region. The sky would get almost completely black because of all that ash in the air. It would block the sunlight. Rainwater would get highly acidic. Fires would keep raging. They would produce enough toxins, harming the ozone layer. Earth's shield against the sun's radiation and heat would weaken. Even though humans would probably survive, the quality of life would plummet, and no one knows how long it'd last. So far, the Venus co-orbital asteroids we have found all share one thing. They follow stretched-out orbits. Their eccentricity is higher than 0.38. Eccentricity is just a measure of how round an orbit is. A value of 0 means a perfect circle. Earth's orbit is 0.017, which is almost a circle. The higher the number, the more oval the orbit becomes. And since these known asteroids follow a long stretched path, they can drift far from Venus and swing closer to Earth. When that happens, we can sometimes spot them during twilight, when the sun is below the horizon but still bright enough to light up small nearby objects. Scientists wanted to understand the asteroids we couldn't see yet, especially the ones with more circular orbits. They ran simulations to study how those lower eccentricity asteroids might move, whether any of them could threaten Earth in the near future, and whether the new Vera Rubin Observatory, with the biggest astronomy camera ever built, would be able to spot them. The results showed something worrying. Even some low eccentricity orbits could bring long-term risk to Earth. Even worse, the Rubin Observatory will only be able to see these objects during short windows at certain times of the year. That means many of them could still slip by unnoticed. Now, this creates a real problem for planetary defense. It's hard to prepare for the danger if you can't see it coming. One way to fix this blind spot would be to place a space observatory near Venus, or even in the same orbit as Venus, so it can watch that region directly. NASA's upcoming NEO Surveyor mission might also help by studying the inner solar system, where these objects hide. In the end, scientists think ground-based surveys like the Rubin Observatory will catch some of these asteroids, but not all. To map the full population of Venus co-orbitals, we'll need a dedicated space mission close to Venus. Right now, astronomers have identified only 20 Venus co-orbital asteroids. All but one have an eccentricity higher than 0.38. These stretched-out orbits carry them farther from the Sun, where telescopes on Earth have a fighting chance to spot them. But there should be many more asteroids with more circular paths that stay closer to the Sun's glare. So, what if we spotted a visitor from Venus when it was already approaching Earth? What would we do? Well, we could launch a bunch of nuclear explosives at the asteroid. If we could just blow it to pieces while it was still far away, the debris would scatter safely into space instead of causing problems near Earth. On the other hand, what if the explosion accidentally changed the asteroid's path and sent some fragments toward Earth? It's a real possibility. Or we could gently nudge it off its course toward Earth. But it would only work if we knew exactly the weight of the asteroid. Without knowing its mass, space agencies wouldn't be able to design a precise mission to knock it off course. In theory, they could send out a reconnaissance spacecraft first, something to get close to the asteroid, measure it, and figure out the best way to push it away. But what if we didn't have enough time for that? By the time we collected all the needed data and built the right hardware, it'd be too late to intercept the asteroid. By the way, NASA actually has some experience with asteroid defense. Back in 2022, they pulled off something groundbreaking with their Double Asteroid Redirection Test, or DART. That mission was all about proving that humans could physically change an asteroid's path without using explosives. NASA launched a small spacecraft in November 2021, and after almost a year of travel, it crashed head-on into a tiny asteroid named Dimorphos at about 14,000 miles per hour. The idea was simple. If you hit an asteroid hard enough, you can slightly change its orbit, just enough to make it miss Earth someday. And it actually worked. The test showed that even a relatively small spacecraft could make a major difference. Now, the European Space Agency wants to double-check exactly how much of an effect that crash had. In October 2024, they launched a follow-up spacecraft called Hera from Florida's Cape Canaveral Space Force Station. Hera's on a 2-year journey to reach Dimorphos and its bigger partner asteroid, Didymos. By October 2026, Hera will enter orbit around the asteroid pair and start collecting data, basically checking NASA's math. ESA scientists hope that once they analyze the impact site, they'll find out how effective DART was at changing the asteroid's trajectory. In any case, planetary defense has to think about more ways to protect the planet from wayward asteroids. It also has to take seriously the things we still can't see.
Did you know that over the past year, around 150 asteroids whizzed closer to Earth than the Moon? But that's not the scary part. It's that some were only noticed after they flew by. And if even one of those had taken a slightly different path, whole cities would be gone. That's what keeps the scientists worried. The invisible stuff hiding where our telescopes can't see. Let's explore what that means. Astronomers keep a list of asteroids that wander into our neighborhood. If a rock's orbit comes close to Earth, it joins a special club we call Near-Earth Objects, or NEOs. That list can include anything from a harmless little space pebble that wouldn't break a window to a rock big enough to cause an earth-shattering kaboom. Neos are leftover materials from when the planets were forming. Some of that rubble ended up tucked safely in the asteroid belt between Mars and Jupiter, but some pieces got nudged onto paths that cut across Earth's orbit. Those are the ones we care about, because they're still wandering around today, looping around the sun, and every now and then passing uncomfortably close to us. The biggest objects are the easiest to locate. They are rare and bright enough that they stand out in sky surveys. So far, none of those big ones seem to be heading our way anytime soon. However, the real anxiety comes from the middle class of asteroids. On paper, many of them sit in the potentially hazardous object category, or PHOs, but the nickname City Destroyer explains them better. These rocks aren't huge enough to wipe out the planet, but they could flatten a city and mess with the climate for a few seasons. Some are as wide as a football stadium and hit the atmosphere faster than a speeding projectile. NASA estimates there are around 25,000 near-Earth asteroids at least 460 feet wide, but we've only discovered a fraction of them. Basically, we have solid orbits for less than half of the City Destroyer crowd. The rest only exist as numbers in simulations. We know they should be out there. We just haven't seen them yet. Why are they so hard to spot? Some asteroids are nearly coal black, blending into the cosmic night. Others hang out close to the sun from our perspective, so our telescopes get overwhelmed by brightness. It's like trying to locate a mosquito while staring directly at the sunlight. Please don't do this. From Earth, these rocks are mostly lost in the sun's glare. We only catch a glimpse just after sunset or right before sunrise. And that chance only exists if the sky is perfectly clear and the asteroid happens to be in exactly the right spot. If not, it slips back into the sun's blind spot, playing hide and seek with us. We were caught by surprise quite recently. In 2013, the Chelyabinsk meteor came from the direction of the rising sun. No one saw it in time because it was coming from the wrong direction. It exploded high above the region, shattering windows across the city and sent more than 1,000 people to the hospital. The scariest part is that the meteor was only about 60 feet wide. Now imagine a city destroyer coming from that same direction. A stadium-sized rock stepping out of the sun's glare would give us very little warning, maybe a few days or a week instead of decades. And we know that the blind zone is not empty. Observations have already revealed at least one large asteroid in that region that scientists can seriously consider a planet destroyer. It's called 2022 AP7, and it's huge. This thing is more than half a mile wide, big enough that if it ever hit Earth, it would be a catastrophic day for everyone. Astronomers found it by using the super-sensitive dark energy camera during twilight, pointing the telescope at the region of the sky most surveys normally avoided. The good news is that AP7 isn't headed straight for Earth. Its orbit crosses the orbit of our planet, but the timing doesn't line up, so we won't encounter it this pass, the next one, or even for several centuries. The bad news is what that discovery hints at. If it took this much effort to notice something like this, what else are we missing? And 2022 AP7 is just one PHO. Other asteroids closer to the Sun were also spotted during those same twilight searches. New simulations say some of those hidden rocks are not random. A bunch of them seem to share an orbit with Venus. They do not orbit Venus itself. They orbit the Sun in almost the same lane, sometimes a bit ahead of the planet, sometimes a bit behind, like kids jogging on the same track but spread out along the lap. Astronomers already know about roughly 20 of those Venus co-orbitals, and their paths are anything but stable. Gravity from Venus, Earth, and other planets keep tugging on them, and over thousands of years, those pulls could stretch their paths until they start crossing Earth's orbit. Most flybys are harmless, but one unlucky pass could be the one that counts. So what can we do about this? The first step is simple in theory. Find them earlier. The goal for astronomers is to launch infrared telescopes and get them into space. While we do have amazing telescopes like JWST or the Hubble Space Telescope, they're never pointed at the sun, as the brightness of our star can damage them. That's why we need a telescope in orbit around Venus, or one that travels along with it. It would be in a much better spot to keep an eye on the asteroids that hang out there. NASA is launching the NEO Surveyor project that aims to solve the problem. It should scan the inner solar system to spot dangerous asteroids in time. Also, we're learning that we can actually move asteroids. NASA's DART mission rammed a small spacecraft into a rock, which affected its orbit slightly. Not by much, just enough to prove that it can be done. It's like turning a plane just 1 degree while it's still across the ocean. By the time it reaches you, that tiny change can make it miss by thousands of miles. Teams around the world spend their days babysitting space rocks, and yes, that's a real paying job. NASA has the Planetary Defense Coordination Office. Europe has the NEO Coordination Center. Observatories feed them nightly sky data, and computers immediately check each dot's orbit. If a rock might wander too close, it joins the risk list and gets extra attention. Each new photo updates the orbit a little more, sometimes that make the danger level rise for a moment. That is exactly what happened with 2024 YR4, when it briefly reached level 3 on the Torino scale before better measurements calmed everyone down. The scale itself runs from 0 to 10, and anything that climbs above 3 is rare enough to raise eyebrows. The whole system works that way on purpose. Notice something strange, collect more data, then decide whether to relax or stay alert. Most of the job is actually pretty dull. It's a lot of number checking, orbit fixing, and crossing out false alarms. That quiet, careful routine is what lets the world respond quickly when a rock finally appears that isn't just passing by. So how worried should we be? For those huge planet-destroying rocks, the short answer is not much. Nothing that size is on the near-term schedule. Smaller city-level threats are trickier. The odds of one hitting Earth anytime soon are still tiny, but they're not zero. Think of it as a cosmic lottery that has been running for billions of years. Every once in a very long while, the universe draws a number that makes astronomers sit up and pay attention. It's not a reason to panic. It's a reason to build better eyes in space and make sure that if a bad ticket ever comes up, we see it in time to do something about it.
Whew, okay, big relief. 2024 YR4 isn't going to hit Earth and wipe out entire cities. But this huge asteroid could still hit the Moon by 2032. The impact could blast a massive cloud of dust and debris into space, putting satellites and astronauts at risk. So NASA is now considering a bold Armageddon-style solution to blow it up. This asteroid was first discovered back in 2024, thanks to the Atlas Survey Telescope in Chile. Now, its official name is 2024 YR4, but hey, let's just call it Nugget for short. So, Nugget is huge, about 200 feet across, which is like a 15-story building. If something that big hit Earth, it would be catastrophic. It could wipe out major cities like London, Paris, or New York, and if it hit the ocean, it could trigger massive tsunamis. Now imagine the scientists' surprise when they ran the numbers and realized that, wait, there's a real chance it could hit Earth. And at one point, the odds were about 3%. Now, that doesn't sound like much, but with city-destroying potential, you want that number at 0, right? That's how this big guy became the first asteroid to trigger a coordinated international planetary defense response. Thankfully, by March 2025, space agencies had enough data to rule out an Earth impact. In fact, there's no serious threat from this asteroid for at least the next 100 years. So that's the good news. But then a new problem showed up. It might hit the Moon. New projections say there's a 4% chance that it could hit our natural satellite in December 2032. The scary part is that the odds might actually be higher, maybe a lot higher, and we might not know for sure until there's barely any time left to do anything about it. Because right now, Nugget is simply too far away to study any further. It's hidden from our view, and scientists say we won't be able to spot it again until June 2028. And only then will space agencies be able to take new observations and confidently figure out whether the asteroid will, or much more likely, won't hit the moon. But what if they actually find out that Nugget is actually on a collision course? I mean, should we intervene? Well, some scientists think we should. After all, it could still be dangerous for astronauts, and it could even knock out stuff we rely on down here, like the internet, cell service, and GPS. If this asteroid did collide with the moon, the impact would be so huge that it would likely be visible from Earth. But honestly, no one knows what exactly would happen, and there's a reason for that. When small space objects hit Earth's atmosphere, they usually burn up. But the moon doesn't have that kind of shield, so it gets smacked all the time by asteroids and meteorites. Estimates show about 100 space rocks hit it every single day, and most are tiny, basically the size of ping pong balls. But an asteroid the size of Nugget is a whole different story. Actually, it's really rare for something that big to hit the moon, and it only happens about once every 4,000 to 5,000 years. And it's even rarer that we know about it ahead of time. So, scientists will probably run a lot of detailed computer simulations over the next few years to see what might happen. But they're already pretty sure the impact would leave a brand new crater on the moon, roughly 3,000 feet wide. And right after Nugget hits, the blast would kick up a massive spray of regolith into space. By that, I mean the dust and small rocks covering the moon. The problem is, we wouldn't be able to predict ahead of time exactly how much material would get launched into space, or whether any of it would reach Earth. Some say the number of tiny space rocks hitting us could jump to 1,000 times the usual level, and that could last for a few days. On the bright side, an event like this could turn into one of the best meteor showers ever. But here's the problem. It wouldn't just look cool. It could be really dangerous for astronauts on the ISS and other space stations. It could mess with satellites and turn into a real headache for all of us down here. And yeah, we definitely don't want that. So, scientists are working on a plan to make sure Nugget doesn't hit the moon at all. And when it comes to stopping a collision like this, there are really only two options: deflect the asteroid or destroy it. Ideally, you just want to deflect it. The idea is to give this asteroid a little push so it changes its trajectory and doesn't hit the moon. And the earlier you do it, the smaller that push has to be. But this method comes with a catch. To deflect Nugget accurately, we first need to know how much it weighs. And that's harder than it sounds, because estimates of its mass depend on its density, which is tough to figure out from that far away. The asteroid could weigh anywhere from 51 million to over 711 million kilograms. And depending on where it falls in that range, the energy needed to nudge it the exact right amount could be completely different. And the problem is that if a deflection mission is based on the wrong mass estimate, you could accidentally nudge it the wrong way. That could make the problem worse, including, in the worst-case scenario, redirecting it toward Earth. So yeah, maybe we should just drop that idea. And scientists basically agree. Which brings us to option number 2, destroy it. Now, there are two ways to do that. The first is using kinetic energy. Basically, you hit it with something big and heavy enough to break it into smaller chunks. We've actually seen this kind of idea work. NASA's DART mission showed that, yes, you can change an asteroid's trajectory by crashing a spacecraft into it. But crashing into a huge space rock with the real goal of destroying it? Well, that's a whole different level of difficulty. Maybe we'll have the tech to do that by 2030, maybe we won't. The second way to destroy an asteroid is something called a height of burst. So basically, you set off a nuclear device close to the asteroid, just above the surface. NASA studies say a 1 megaton nuclear blast would be enough to destroy Nugget, no matter what size or how heavy it is. We have never actually tested a nuclear detonation in space specifically to deflect an asteroid before, but the physics says it can work. So at this point, it's not just a technical call, it's more like a big global decision. Authorities still need to figure out if it's worth doing all this for this particular threat. And remember, for now, there's still a 96% chance this asteroid doesn't hit the moon. So we just have to wait a few years until it comes back into view to update these numbers. All of these plans are still just possible scenarios that space agencies are talking through. And any final decision would be made over the next few years. The timing would be pretty tight though. If they want to be ready for 2032, a nuclear mission would have to launch sometime between late 2029 and 2031. Now, even if Nugget never hits anything, tracking its trajectory and thinking through how we'd stop it is still a really valuable test run for planetary defense. And keeping an eye on threats like this is only getting more important, especially as space agencies move closer to building bases on the moon, where astronauts would live and work. The United States plans to start launching regular missions to the moon before NASA eventually heads to Mars. China has similar plans too, and has said it wants to land its astronauts on the moon by 2030. That's why we need sharper tools and better prediction, so everyone can stay safe up there in the future. And hopefully, Nugget, or any asteroid like it, never becomes a threat to us.